A pad building with crane, an aircraft hangar with Staad Pro ECOONECT 2023. A tutorial series by Siraj Biswas, Chartered Engineer, Institute of Engineers, India. BE in Civil, National Institute of Engineering, Mysore. Gold Medalist of Engineering Stream, University of Mysore. M.Tech in Structural Engineering, IIT Delhi. Sun Certified Java Programmer, Sun Microsystems, USA.
Earlier, I told in this series, design of an aircraft hangar with a design of a PV building with a crane, in which I have taken an aircraft hangar as a design example. I had told that I will make the same model in eConnect version at the end of the tutorial. But some of my friends has requested to put this in eConnect version. So I have decided that I'll put along with the parallelly I will work in eConnect version as well, so that those of my friends who are having eConnect version with them, they can also learn to walk in Start Pro. The reason is being that the Econnect version, the uh, Start Pro 8A version has been uh, discontinued by Bentley. So whatever new licenses are we getting, it is Econnect version also. So I am going to continue parallelly in Econnect version also for this aircraft function aircraft hanger. So first we'll go to a new, then select the folder, then give the name and aircraft hanger. So metric is already chosen. The next point is create. So it has been created. So to to know about the geometry, you need to visit my YouTube channel in the playlist of this PV region of PV building with structure with crane and aircraft hanger. In section on where I have given a 3D model in which I have discussed the geometry and many other things. So you need to see that tutorial is in Hindi. So I am making this eConnect version in English so that those who are comfortable in not comfortable in Hindi, they can follow this section. And those who are following the हिंदी लैंग्वेज, उनके लिए मैं कहता हूँ कि आप हिंदी लैंग्वेज का पहले देखिए, उनके बाद फिर इस इंग्लिश को भी दिखे, देन विल आपको सारी चीजें समझ में आ जाएगी. So we had the geometry. First, we need to make the grids. So let us take the beam grid, then edit exit plate. Okay. Now our building has a length of 46 meter and a width of 35 meters. So go to edit. Then let us make in x direction 35 meter and in z direction 46 meter. So okay. So we have the outline of the building. So now I'll take snap and node beam, then draw the beams, these beams, then these beams, then press Control. Uh, if you do not press Control, then this line will be created. So if we press Control, then this line will not be created. Then select the node and then make this beam, then make this beam. So we have the outline beams. Now our uh, we need to make a 2.5 meter width bay, two numbers of 2.5 meter width bay, and on five numbers of 8 meter width bay, and in between them there is a gap of 500 mm. So go to geometry, translation repeat, along z direction. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 numbers of a step. Our most of the grid spacing are 8 meters, so let us put it 8 meter. Then first bay is 2.5 meter. Then there is a gap of 0.5 meter. Then all others are 8 meter. Then lastly again there is a gap of zero point 0.5 meter, and then 2.5 meters. So click OK. We have to select the member which to translate. Okay, click OK. So we have got the position of the column. Now we have to need to know the in other direction also. So copy. In this direction there are 5 meter base and 25 meter, 5 meter and then 25 meter and then 5 meter again. So geometry, that is translation repeat. Now we need to take it in along x direction. So the mid on is 25 meter. So now unlike ETAP, the columns cannot be columns are not shown when we select column positions are not shown when we select a plan view or cut section anywhere. So to make way out of that, we'll assign support at those positions where there is a column. So Shift K will bring the node position visible. So let us create a support. We'll create this support when we'll start analyzing the model. For creating the geometry, we'll keep this support. So we have all along this line we have support columns. All along this line we have support. Uh, Press Control and then select. So assign. And this is the part. This is the part where will be the sliding gate will be placed. Uh, I had discussed in the 3D view. So this part will also have columns. Assign. So now our column positions has been fixed. Now we have to decide the clear height according to the architectural requirement. The clear height was 11. Clear height was is about 10 meter. This will have to adjust. May require to be adjust when we detail the crane bridge and when we see the clearance required here at this part. So as of now in 10 meter, but in my Staad Pro V8 model, I have taken it center to center distance 11.1115. If you see the crane detailing, uh, section, you come to know why this has been done. There will be around 250 mm will keep below the finished level. So around 800 or 900 will be the depth of this beam. You can see. So since start makes a center to center model, so if you add up or considering all these things, you will get 11.15 as center to center distance from base plate to the this center at this point center at this point. So we will take all these columns which are making the 40 meter span clear span as to a height of 11.15. So geometry, translation repeat y 11.15, link step. Okay. So our this column has been created. Now the part where the uh, sliding gate will be there. For that part, we have to see in the architectural drawing what has been given. So you can see it is around 8.5 meters. So 8.5 meter plus 0.25. So after creating this main column, we have to create the secondary column. Now the height of this uh, column at the sliding gate portion is, again, if you see the architectural drawing, you will see it will come around 9.05 from the base plate to the top of the at the center point of the beam. 25-meter span beam, there is 25 meter is here, this one 25-meter beam. So let us select these four nodes, eight nodes actually. 1 2 3 4 5 6 6 7 8. Again 1 2 3 4 5 6 7 8. In total there are 8 into 8, 16 column. So go to geometry, translation, repeat. Y is equal to 9.05. How I am getting this distance and grid, etc. You have to visit my Stat Pro V8 tutorial in Hindi. That will give you a better picture how I get. I am getting this. Am I getting these values? My main intention to uh, teach you how to create the geometry and load and design with ECOONECT version. The basic design concept remains same. So we have this column. Now let us give some properties to these columns. So let us take some section as we had taken in V8I Start Pro V8I tutorial. So we will take go to legacy. Let us take Indian sections, ISMB 600, ISWB 600H for the columns, then again 600H for the Raptor, then ISMB 500 for the column in the part of the sliding gate, then ISMB 500 again for the column in the part of sliding for the beam in the part of the sliding gate. Then we will take ISMB 300 for the smaller beam. Then we'll take some pipe member as well. In Indian section, pipe will take 100 pipe nominal bore. 100 nominal bore is 113 This we have added. Then we'll take 125 also. 125 nominal bore. So that will come 139 7 Add. Then we'll define some rod bracing member also. So let us take steel prismatic section and then select steel. YD is equal to 0.016, 16 diameter. Add. Okay, this has been added. Now let us assign view. Go to side view. These all columns will be ISM 600H, and these columns will be 500 ISMB 500. As I have already discussed, so we start with initial. Initial will not take this. Uh, will not define tapered I section from this, because if you insert node, the start creates lots of members, then it's become very difficult to track those members. After completing the geometry, we'll shall change all this standard section to built up section. So this has been assigned. Now let us make the raptors. We do not need this bottom view anymore, so let us delete them. Yes. So now let us go and make the raptor geometry, add beam. So this is our raptor. So insert a node, add midpoint. So utilities node to node tool, node to node distance. This is 17.5. So usual P our slope is 1 is to 10. So we have to raise this move this point by 1.751. 17.5 divided 10 is 1.75. This has been moved. Now let us assign property to this raptor. Assign. Then copy this raptor to other places. Reference point 1, 2, 3, 4, 5. So now let us go to the columns columns to add beam at the sliding part of the gate. So check the top node is node 198, utilities structure tool, cut section, exit plane 198. For in your cases could be a different node depending on how we started the modeling. So geometry, add beam. Sorry, we have to add like this. 1, 2, 3. Then these are ISME. We shall assign ISME 500 to this. Assign. Then copy it. Copy. Paste beam. Reference point. Assign. Assign. Paste. Then we'll make the smaller beam as well. We'll keep them simply supported. ISME 300. Let us select this beam ISME 300. Then go to specification beam. Release. Start MIMZ. Add beam. Release. End. MIMZ. Add. Then select this one and assign. Then assign. Here we'll insert node at every 5 meters. So let us insert node at 5 meters. Insert node. There will be 4 points to do that. So we have this now. Let us measure the distance to be ensured node to node tool. 5 meter. Okay, that is very fine. Copy. Paste beam reference point 1, 2, 3, 4. Now this point do not have any column, so we have to assign so that we do not get confused at later steps. So assign no support here. Now go to properties, select this ISMB 300 and copy, paste beam reference point. Okay. Now we'll have add a roof brace at this level as well. Go to geometry, add beam. This will be rod section, 16 mm diameter. This will be tension member. So we are adding it. Now select the circular section and go to property, go to select missing properties, assign. Now we'll give this rod member a tension member, tension only, assign. Okay. Now copy this, right click, copy, then paste beam, take a reference point. This is the reference point already is taken by Staad. We can use the same and assign it here. So now we have to assign a if stud at the if point. So let us go to the geometry, add on member here. So we'll assign this nominal with nominal bore of 100 mm. So now this has been assigned. We have to provide a specification that this should not carry any bending. it should only carry axial load in either compression or tension. For that, is plus is the specification. So add. So select R6, assign. Now we have to take this E start at the other side also. Take a reference point, paste it here. Now we have to add a start at the crane bracket level. That is around 8.5 meter from the top of the base plate. So let us select this section R1. This is also R1. It has somehow has become R3. So R1, assign, then select insert node. Before that, we should always keep on performing one thing. Go to beam, go to utilities, beam tool, beam incidence, set the incidence of order of the selected beams so the start node is closer to the origin than the end node. Select this array button, OK. Now select this ISMU 600H column, insert node at a distance 8.5 meter. OK. So we have this. Now let's select this start, copy, paste beam, reference point. We can take anywhere as the reference point or default selected by the truss, and accordingly we must paste. So let us rotate this model by side, left and right key, or uh, top and bottom key. Using that we can rotate. So we have assigned a start. Now at the center point also we need to have some struts. So we select all these beam, then all these columns, then insert node, add midpoint. Okay, midpoint is added. Then we already had this place start selected. So paste, take the same reference, same thing, and paste it here. So our start has been added. Now next thing is to add start at the roof raptor level. So select, we'll insert two nodes at each raptor. So insert node, add endpoint 2. Okay. Now I can select only this strut, copy, paste beam, reference points, take a reference point, then paste all these struts. Now this strut doesn't have any column at this position. So let us go to no support and assign them no support. Assign. Okay. Now at the top level also, roof level also, we need to provide tension bracing. Again, we'll provide some rod bracing. Go to geometry, add beam. These will be our rod bracings. Roof level bracings. Go to properties, select circular section, select by missing property, okay, assign. Then go to 3D view, display whole structure. Now up to the frame top level, we can take rod bracing because above that there is a light roof only. So rod bracing will be able to sustain that. So you go to geometry, add beam. Now we have added bracing at this level also. Now keep property to this bracing as well. Select by missing property, assign. Now all this rod bracing of tension member, to go to a specification beam tension only. We do not need to select it. We can use it from earlier created tension member. So assign them. Now below the crane bracket level, we should have uh, pipe section or tube section as a bracing member, because the crane creates vibratorily longitudinal forces. So it is recommended that we should not provide rod bracing below that. A pipe or pipe bracing or tube bracing is more suitable to take this kind of vibratory load. So obviously, with the for this model, we will take them tension member only, not as a truss, but tension member. So their stiffness will be obviously high, much higher than the rod bracing. So we will assign nominal or 125 here, assign, then specification beam, tension only, assign, okay, assign. Now copy this to other side also, copy, page beam, reference point here, okay. Now our next part is to add the crane girder, gantry girder, not the crane girder. Crane girder is the crane bridge. So for that, we have to go to the crane top level. Geometry, select node 2 244. One of the node as crane top level is gantry girder top level is 244. So cut section, exit plane 244. So we have reached the gantry top level, bracket top level. It is not gantry top level. So our bracket is shall be 610 mm, as I have discussed in my train details section, from the center of the column. So copy this all this node, geometry, translation, repeat in x direction. Now at this level, you have to create the current indicator. From the train details in earlier sections discussed, we know that the crane bracket length from the center of the column is around 610 mm. So select this node, then go to geometry, translation, repeat, Z 0.61 meter, link step, okay. It is not, it is in X direction, geometry, translation, repeat, X direction, 0.61 meter, link step, okay. Then select this, geometry, translation, repeat, minus 0.61, link step, okay. So let us assign ISM 400 to this member. We had taken ISM 400 and ISMB 600 in structure VHI tutorial for this. So here also we are taking the same member. So select ISMB 400, select by missing property, assign. Then let us add the gantry girder geometry, add, add. So select ISMB a 600. If it is not there, then we can select it, take it from here. Indian section, from the Indian section we can take it. So again, go to select by missing property, assign. Now this gantry cutter are simply supported beam. So go to beam specification, release, start MIMZ, beam, release, end, MIMZ. So now copy this gantry cutter to the other side also. So gantry cutter at the bracket top level has been created. Now, as of now, their standard section will change them to the design section at a later stage when we will perform the design. Now, the last part is we have to make vertical members at the gable end to provide closure for this part, so that guard can run along this. So let us select this member. We know this beam is 500 away from this beam. So select all this node, copy, select, select, then select geometry, translation, repeat, Z minus 0.5 link step. Okay. Now let us take ISMB 300 for this member. Go to Indian section, ISMB 300, ISMB 300 add, select by missing property, assign. Now these members have been created in opposite direction from the start. The start node is not near to the original, so we have to change it. Go to utilities, beam tool, beam incidence, switch incidence of the selected member. Now select this node to make the vertical member of select. Then geometry translation repeat. Y is equal to 5 meter link step. Okay. Now select all these vertical members with beam cursor. At times there will be no cursor, then you have to press escape or take from the menu bar the beam cursor. So then select the reactor, geometry, intersect. They have been intersected. Now delete the top part, delete. Now assign them also as a 300. Select by missing property, assign. Now this member doesn't have this corner doesn't have a column, so we should not get confused. We have provided support to know the locations of the column whenever we go to the plan views. So go to support, no support, select these two nodes, assign. We have to make similar member on the other side also. So let us take this horizontal member, copy, select, copy it, paste beam, reference point. One of the reference is already taken, so paste it here. Then you have to again I have support has been created. Select this node, no support, assign no support. Then select the vertical members at the other cable side. Copy, select, copy, paste beam, reference point. Now, as we have discussed uh, in the first section, this point will keep movement connection. The other part will release. So let us select this horizontal member first. Go to specification beam, release, close it, start, assign. Then select the vertical members. And MIMZ assign. Then here also you have to do the same thing. Here for both the members, the end will be released. End assign. With this, the initial geometry with ECOONECT version is complete. So in next section, after modeling in extra Staad Pro V8i, the loading part will do the same thing in ECOONECT version, but here there is nothing much difference. The load combination will copy from the Staad editor of V8i to the ECOONECT version itself, so that will be sufficient. So this tutorial is just to let you know how to model or do the things in Staad Pro ECOONECT version. Along with the Staad Pro V8 version, I'll keep on posting short videos with along with the Staad Pro V8i version. Well, I will keep on posting short videos with ECOONECT version as well. So Let us have a look at the 3D. So our geometry almost looks like whatever we did in Staad Pro 8 version. With this, we complete this section.